Let's begin. Today is May 5th, 2024, and we're going to do our daily Turing Machine Puzzle. But first, I want to share with you how we can get more information on the board game Turing Machine. First, go to Turing Machine Info and then click on the Download Game Rules. So the game rules will give you a wealth of information on all the parts and pieces that make up the board game Turing Machine. But I want to zoom in on page 2 and share with you that within the purchase of the board game, you are given an initial 20 questions or problems to solve. Of course, you can always go to turingmachine.info and play the daily puzzle or even generate original games. The second thing I want to share with you about the board game is that not only do you get to play classic mode, which we do with the daily puzzle, but the board game actually comes with 2 additional levels, an extreme level and a nightmare level. And this offers you more challenging puzzles to solve. Okay, well, let's go back and solve our daily puzzle. And we see that we have a 5 criteria puzzle today. Our first row of criteria cards, known as criteria A, B, C, and the bottom 2, D and E. So criteria A allows us to determine whether the middle digit, the square digit, is even or odd. Criteria B allows us to determine the quantity, the number of 3 digits in our code. Are there 0, 1, 2, or 3 digits in our code? Criteria C allows us to determine which of the 3 digits is the largest. Could it be the triangle that's the largest, or the square, or the circle? Criteria D counts the number of even digits in our code. Is there 0, 1, 2, or are they all even? And lastly, criteria E lets us to determine whether there is a pair or a duplicate digit in our code. As in the example 131, it's the one that's paired up. Or, alternatively, could the 3-digit code have all different digits, as in the example 134, or potentially the an identical digit repeated 3 times? Okay, well, we've already started with our proposal of 3, 1, 4. So I like to focus on criteria A and determine whether the middle digit is even or odd. So I'm going to test A, and the Turing Machine tells me, no, it is not correct that the middle digit is odd. So that means that the middle digit must indeed be even. So I'm going to go into my notes section, and I'm going to label and say that square is an even digit. And then I'm going to come above here and cross out all of the odds. Since it can't be odd, it can't be a 1, it can't be a 3, and it can't be a 5. So it must be even, 2 or 4. Okay. I now see that I also have a criteria D that tells me how many even digits there are. So let's test D. So the Turing Machine says, no, there is not just one even. So we know obviously it's not 0 because the square is even. The Turing Machine just told us that 1 is insufficient. So that means that criteria D tells us that there must be at least 2 or potentially 3 even digits. So there are 2 or 3 even digits. All right. Now, since potentially we could have a pair if there are 2 or even 3 even digits, let's test criteria E and see, do we have a pair? Okay, so since my proposal is 314 and I have no repeated digits, and the Turing machine confirms that, that means that we do not have a pair. They must all be distinct. So in my notes section, I will write down that all 3 digits must be unique. So first of all, let me rephrase that. Technically, I don't know that they're all unique because all we determined is that it's not a pair. So there is a potential for them to all be different or all be the same. But actually, one of the criteria cards gives us a subtle hint that indeed it must be all 3 digits must be unique. Can you see which of the 5 or the 4 remaining criteria cards give us that subtle clue? Well, in fact, it's criteria C. The reason is this criteria tells us which of the 3 digits is the absolute largest. So if we have an absolute largest digit, then obviously all 3 cannot be the same. So technically, it is true that all 3 digits must be unique. Okay. Well, that does it for the first round. We've done our 3 Turing tests. Now we have to come up with a proposal for the second round. Okay. So let's review. We have the square is an even digit. So we know it's 2 and 4. 2 or 4. Criteria D told us that there's 2 or 3 even digits. And E tells us that they all have to be distinct. Okay. So, criteria D is rather important. Notice that in combination with D and E, if we have 2 or more even digits, 2 or 3 even digits, and E is that they all have to be unique, that actually means that there can only be 2 even digits. Remember, we can't have a pair. So that means that we definitely have to have a 2 and a 4, and no longer 3 digits. So I'm going to update our D notes here and say there are 2 distinct even digits. So, in other words, 2 and 4. So I know there has to be a 2 and a 4. So these 2 criteria lead us to this conclusion. And of course, there must be an odd digit. So we have 2 and 4 for sure. Now the question is it going to be a 1, 3, or 5? And where? Okay. Well, obviously a 5 would be the largest. So we can maybe conclude that it could be a 5. And what else have we not tested? We haven't tested B or C. We don't know which one's the largest and whether there's a 3 or not. Now notice, so criteria B, counting the number of 3s, well, there's either 1 or none, right? So that will tell us whether we're going to use a 3 or 1 or 5. So let's see, how else can we use our proposal? So notice that this is interesting. Criteria A does point to the square digit, and the largest points to, either, well, it could be any of the 3 technically, but there's nothing that, is either triangle or circle exclusively. So somehow in our proposal, trying to figure out what the 3-digit code must be, this unique 3-digit code, that by default, the other must be obvious. So we have to sort of think about how we can construct our proposal to achieve that. So if I have a 5, do I have, well, okay, so this is what I think is going to happen. So square is even. The largest, potentially, I'm thinking maybe a 5. So it's either triangle or circle. And then the other one by default must be a different even. So in fact, I'm kind of changing my mind. I'm thinking that maybe the square, if the square is a 4, that would force the other, triangle or circle to be a 2. And then potentially now maybe a 3. Because, well, it could be 3 or 1. Yeah. So if we're told that 3, there is no 3, then it must be a 1, since we're saying that perhaps the square is the largest. So I'm thinking that the square is going to be a 4, and between triangle and circle, I'm just not sure which one it could be. So I will say 3, 4, 2. So my proposal is 3, 4, 2. I'm thinking that yes, there may be a 3. If not, it may be a 1 if it holds that the square is indeed the largest and it's even 4. And well, yeah, let's try it. So 3, 4, 2. Okay. So I'm going to hold off on confirming what the largest is. And I want to test whether there's a 3 or not. So that would be criteria B. Okay, so it's true, there is a 3. So in my notes, I'm going to say there is a 3. Okay. And then, but again, I don't know which one it is. So that is interesting. Yeah, I'm not sure if that's going to work out. So even if it is bigger, let's see. That is interesting. Okay, well, let's go ahead and try. Yeah, let's verify C. Is square the largest? Okay, it wasn't. Okay, so that didn't pan out exactly as I wanted. So we know that then square is not the largest. So either the triangle or the circle is the largest. So either triangle or circle is the largest. So triangle or the circle is the largest. All right, so since square is not the largest, well, I've already eliminated 1 from that possibility. What else can we do? So we already know for sure A, right? We know it's an even digit. We know D, I think by conclusion, we already established that there's 2, so we don't need to test that again. And E, that they're all unique. Okay, so it makes no sense to make any other guesses on this proposal. We need to now adjust and figure out. So if 4 is not the largest and they are all unique, yeah, I guess potentially it can Well, it can't actually, because there is a 3, that means none of the others can be a 5. So that means we can eliminate 5 from all of them, since there is a 3 and there's only one odd. Okay, so, well, that's very interesting. Okay, so that means if square is not the largest, so that means it must be a 2. So that means 4 is invalid for square. So square cannot be a 4, so it must be a 2. And so that means, again, we're looking for another 4. And so that would lead us to have the largest be a 4. So either triangle or circle is a 4. And we just have to, it's a 50-50 flip. There's no other clue that I can think of that will help us determine that. And then by default, the other digit is going to be a 3. So down here, I'm just going to type in what I believe may be potential solutions. So if we pretend the triangle is the 4, so it would be 4, 2, 3, or circle would be the 4, then it'd be 3, 2, 4. 3, 2, 4. Okay, so just to kind of think about this, again, there has to be a 3. Both of them have a 3, and the other 2 digits must be 2s and 4s. So if the first one's 4, square is 2, circle is 3, vice versa, it's that the triangle is 3, and 3, 2, 4. Okay, it's a 50-50 flip. I'm just going to go with 4, 2, 3. And we just need to test. Oh, sorry. So in my little program, I actually have to tell it to skip to the next round. So I'm just going to type in the letter N. And now it's prompting me to enter my proposal. And I believe I said 4, 2, 3. Again, it doesn't really matter. And all we have to test is which is the largest. Is it C? Is it triangle or circle? So I'll test C. And okay, so I got it wrong, but that's okay. Getting wrong information leads us to getting the correct information. So in our case, my proposal had triangle be the 4, being the largest. That's not true. It must be the circle. So it's the code 3, 2, 4. So let's type it up here, 3, 2, 4. And before we go to the official Turing Machine verification, I want to actually check it within our puzzle here. And so is the square digit even? It sure is. Is there a 3? Yes, there is. And again, let me update our code, our notes here, where it should be circle to be the largest. So let me get rid of this. And we know that circle is the largest. So circle the largest, yes, it's 4. Again, we sort of deduce that there should be only 2 evens since there is a 3. So yeah, there are 2 evens and they're and an odd digit, and they're all unique. So I feel confident that 3, 2, 4 is our solution. So let's go to turingmachine.info. We're going to go to the daily challenge, and we're going to test our code. And again, we said it was 3, 2, 4. 3, 2, 4. 3, 2, 4. And let's verify. All right, congratulations. We got it. Excellent. Now, the question is, did we do it in or did we beat the Turing machine? So we first tested ADE. So let's type that in. ADE, and I believe E was the only correct one in that turn. That's right. Then we tested BC. BC. And we had one more round, one more proposal, and we verified and tested C again, and we got it wrong. But that again, wrong information is also helpful because it lets us eliminate invalid options. So let's see, did we beat the machine? No, we did not. So notice that we both asked 6 questions, but the Turing machine made those 6 questions in 2 rounds. It took me a 3rd round to conclusively figure out that unique identifier. So we got in the same amount of questions. It just took me 1 additional round. Okay, well that does it for today. Thank you. Have a great one.